In lesson 4.2, constant rates of change, we're going to work on the standard 7-point RP2, which is ratios and proportions. Recognize and represent proportional relationships between quantities, and also we're going to be working with the standards 2A, 2B, and 2C. So our essential question is how can you identify and represent proportional changes? A couple of things that I want to talk about. I want to talk about this word constant. Constant, the way that we're going to mean is that it's unchanging in a proportional relationship. Constant is represented by the letter K. I've drawn that here, the letter K. Now to extend this just a little bit further, the way that we find constant is we're going to set that equal by taking whatever letter or whatever value we find for y and divide that by x. We've talked about y and x. Y is the dependent variable, x is the independent variable. So I have some information here to help us out. I've drawn up this equation that we have here where k is our constant equals y over x. So if you remember, as a fraction, the y is divided by the x value. So the y is our dependent variable and the x is our independent. So the question is that you have to figure out, and this is what we'll do through class, is who controls who? Does the dependent control the independent, or does the independent control the dependent? And the example that I like to use is, think about a parent-child relationship. Who controls who? Does the parent control the child, or does the child control the parent? Well, of course, the parent controls the child, so the parent is the independent. The child is the dependent. A couple of variables that you'll come across a lot is, does time control distance, or does distance control time? So which one will these be independent, which one will be dependent? Also, that we have the equation y equals kx. So once you find the value of k, okay, because you're going to be given the values of y and x in a table or a graph or coordinate points, and then you're going to substitute them into the positions here to find k. Then what you do is you take that value that you just found for k and you substitute it here, and you rewrite the equation then. Y equals some number, so let's say that k was found to be 5, and so k is 5x. So that's your equation. I highlighted our information here already in the word problem. So we have 3 seconds and 10.5. It takes a giant tortoise 3 seconds to travel 10.5 inches. So the question you have to ask yourself now is, who controls who? Does the 3 seconds, our time, control the distance, the 10.5, or is it the other way around? It's going to be that time, which is going to be our x, is going to control our distance. How long you go in time is how far you will go. So the equation k equals y over x, and I substitute the numbers in. So I'm going to put 10.5, 10.5, because that's my y, over my 3, and you do the division, and that comes out, and they show us right here, comes out to that. So this is our constant rate of change in a proportional relationship. And the way you look at here is does that constant rate of change apply for all three of them? So does it apply here, here, and here? And if the number does, then you have a proportional relationship. So I've gone ahead and I filled in the values. So the distance is 3.5 in 1 second. So if you were to put the x here and the y there, okay, so that you can keep them. And what this part does down here, it just rewrites that in the proper format of k equals y over x. So this is our y, 3.5, that's our x, 1. And if you do the division, 3.5 divided by 1, you get 3.5. Go on to the next one. 7 goes in the y because it's the y position. 2 goes in the 2 position because it's the x value. 7 divided by 2 is 3.5. So we go ahead and we continue doing that from our table. And what that shows us is that our k is 3.5, and it shows up in every one of these. If all of these numbers are the same, you have a constant of proportionality. That means that they're all the same. If I go one step further and I simply take this value of k and I substitute it in place here, so now y is going to equal 3.5 x. So what that means is I'm going to take 3.5 times any number that I substitute in for x, and that's going to tell me how far it goes. So in the context of the problem, if I say I have 10 seconds, so I would go 3.5 times 10, and that's going to equal a distance of 35 inches. So proportional relationship is a statement that two rates or ratios are equivalent. So if we look here, we have 6 miles over 2 hours, and if we reduce those, if you think about fractions and simplifying or reducing the fraction, that's what you're doing. So you take this, you simplify it, 6 divided by 2, that gives us 3 over 1. We talked about that in 4.1. A rate of change is a rate that describes how one quantity changes in relation to the other. So what that means is that for every hour change that this increases, for this example here, your distance is going to increase 3 miles. So at 2 hours it's going to go 6 miles, in 3 hours it's going to go 9 miles. And then here they just give you another example here. A proportional relationship is when the two quantities which the rate of change is constant and one in which the ratio of one quantity to another is constant. So it's what we just did there in the earlier example where we found that 3.5 was our K, or our constant of proportionality. In this example, you're given a table. Okay, so you have amount earned and number of days. What we have to figure out is what's going to be X, what's going to be Y. Who controls who? Are the days going to control how much money that you earn, or is the number of amount of money that you're going to earn going to control the number of days? If you think about that, I'm pretty certain that the number of days that you work is going to control how much that you earn. So that's going to be X, and that's going to be Y. Down here in step 1, they've gone ahead and set it up. They've taken, remember using the equation, K is equal to Y over X. So the X is in the top, Y is here in the bottom. Don't always assume that your table is going to show X on top, Y. You have to figure out that independent versus dependent relationship, and that's how you determine which one is X and which one is Y. So the beauty about this is that this is also our unit rate, okay? Because it's something over 1, all right? So 16 over 1. So once we know that unit rate, we can always find anything else. If I say, tell me how many days we're going to be at 10, or if we're at 10 days, how much money do we earn? We can simply say that, well, we had to multiply 1 by 10 to get this. So what I do up here, I have to do down here. So I take 16 times 10, and I'm going to get, my answer is going to be 160. So if I work 10 days, I'm going to get $160. And here what they're doing is they're showing you that the K is constant, okay? All of this is K right here. They're taking, you have to make sure that every one in your table, the proportionality, gives you the same number. If it gives you the same number, you have a constant of proportionality. So here in the your turn, you can see that Allison was giving you some information. Typically, time is going to go ahead and be the X value. We've talked about that in class already. And so I'm going to label these as X to Y. Okay, this is your unit rate. So everything has to be compared against that. So that's going to be 65 over 1. Then you have 120 over 2. So if this is a rate, not a unit rate. So 120 divided by 2 is 60 over 1. So if we make a comparison now between this one and this one, we see that the two are not the same. So we can stop right here and tell, was she driving at a constant speed? No, she was not driving at a constant speed because her rates were at different rates, the different constants of proportionality. So in the next example here, they're talking about the equation again. Okay, so here's the y equals kx, and then of course here's the k equals y divided by x. K is the constant of proportionality. In the example, I've highlighted the information already. So 2 pounds of cashew cost $19 and 8 pounds cost $76. Show that relationship between pounds and cost. Then write an equation. This is where you guys make a lot of mistakes. You don't pick up on this additional information that you have to do. And describe the proportional relationship. So they've made a table, okay, number of pounds and then cost. So they're talking about make a table relating cost in dollars to pounds. So the order that this is written in is the order that you're going to write your table in, okay? And that's where you make your ratios. So does pounds control cost, or does cost control pounds? Well, I think the number of pounds that you buy is going to control your cost, okay? So this is going to be our X, and this is going to be our Y, okay? Now down here, this is Y, because remember Y goes on top, and this is X, because K equals Y over X. So then you take your numbers. 19 divided by 2 is 950. 2850 divided by 3 is 950. 76 divided by 8 is 950. So they're all the same. So the K is 950. In step 3, we're going to write the equation. So we simply take that 950 and we substitute it in place for K. So Y equals 9.50, and then we just say X. So this means to multiply 950 times whatever value of X is, which is cost. So in the your turn here, I've highlighted the important information. On a school field trip, 1 adult for every 12 students, 3 adults for 36 students, and 5 adults for 60 students. Show the relationship between the number of students, so we're looking for K, and then write an equation. So Y equals KX. So, does students control adults, or do adults control students? Well, adults control students, so it's X and there's Y, okay? So, notice it changed here from before, okay? Always, who controls who? Independent variable controls the dependent variable, okay? So now it's already in our format, so K equals Y over X. So then we just do this. 12 over 1 is 12. 36 divided by 3 is 12, and 60 over 5 is 12. Is K constant? Yes, it is. So then we take that value and we substitute it into the equation. So now our equation is going to be Y equals 12X. So for any value of X to have 10 adults, then it would be 12 times 10, and I would be able to get 120 students. You have the guided practice here to finish up on the end, and I hope this helps you.